Okay, let's talk rotations. Now, we did investigate this one in class, but that shouldn't worry you, because if you notice kind of reflections and translations, a lot of the principles were the same. So we'll still be kind of looking at like what's the important parts of the rule and how can we tell what's going on by the rule. And then we'll also be looking at structure as well, but we'll just be doing it together right now because I think, like I said, like a lot of those arguments are going to transfer quickly. So let's talk about rotations and let's talk about how you can identify and perform them on and off the coordinate plane. So let's start with this. So this is a natural thing to think about when you're investigating anything, is you got to kind of think about the rules. So let's establish first some ground rules for rotations. So if I'm going to be performing this kind of motion, the very first thing that I would have to establish is that one rule applies for everything. And there's going to be an exception to that that we'll kind of encounter as we go. That's rule one. Rule number two is that all rotations are assumed counterclockwise. Man, I don't know what's happening with this. Okay, so that's a mathematical standard. So if you think about the coordinate plane, what I'm saying is that all the rotations are going to happen in this manner. There are exceptions to that rule, like when it states it directly, and also with negative angles. And so, like, we can put a little side note here. A negative angle is clockwise, and I will demonstrate what that means when that time comes. The third rule is that the important parts are going to be the angle of rotation and going to be the center of rotation. So this little symbol right here just means angle. So if you want to make a side note there so you're not confused later, you can. That's just a shorthand for angle. Okay? So these are going to be our rules. The important parts are the center and the angle. All rotations are assumed counterclockwise, and one rule applies to all the x, y, and the exception, which I'll note now, is except for the center. Okay, so let's start with a common rotation. So let's do this on the coordinate grid, and let's just go ahead and go 90 degrees. So if I have this, and let's just say I have a couple points here, I'll make it really easy. Let's say 1, 2, 3. And so you can kind of roughly see the triangle that's being formed between these three. And we should probably go ahead and coordinate them. So that's going to be, whereas iPad, since the update, has gotten so much worse. Okay, so that's going to be 2, 1. Let's see, 1, 2, 3, 4, 5. So that'd be 5, comma 1. And we'll call this one 2, comma 3. Okay. So what I'm trying to do here is to take this and rotate it 90 degrees about the center of rotation, which shall be 0. Let's change that color actually. So let's make that the center of rotation. Okay, and then the angle of rotation equals 90 degrees. So I'm going to kind of copy and paste this so I can kind of manipulate it and talk my way through this. And so the idea here is we want to take this thing and we want to rotate it kind of like this. Okay, now the easy mistake that you can make is that you're assuming it should just rotate like this. But if I were to rotate like this, my center would no longer be the origin, which I pre-identified and is kind of a default. So unless otherwise noted, the center of rotation will always be the origin. And if you're wondering why this is not the proper rotation, ask yourself what is not moving. And so if you look at this rotation, what is not moving is 2, 1, which means if I do it like that, the incorrect way, that's my center of rotation. Um, what I need to do instead is rotate it so the origin is not moving, which is a whole lot more complicated. And so again, like I claim it had to be more like this-ish, something like that. So this is pretty tough to do outright. You have to do this so without any kind of basis, just kind of guessing. So let's take a kind of quick aside here, and let's talk about the rules for rotating. And so, like reflections, these rules are okay. There's nothing wrong with them, but they're not going to be really universally nice for us. So here's kind of the algebraic rules for rotating. So if you're rotating 90 degrees, the algebraic rule is that xy shall travel to negative y comma x. If you're traveling 180 degrees, this is going to be xy traveling to negative x negative y. And 270 degrees, you're traveling to, I'm sorry, from xy to y negative x. So just if we're wondering where I'm getting all of that, like that's just something I had memorized a long time ago. You can look it up and you can find those rules really quick. But I'm going to make this kind of side note here that these are extremely limited again. And so we saw that with reflections. They were limited because reflections just don't happen over the axes. And so same kind of thing is true here. They're limited because this assumes the center of rotation is 0, 0. So unless your center rotation is 0, 0, these rules don't even apply. So although that will totally get the ball rolling for us, maybe extracting some other stuff, just know that these rules aren't that great. But they're good enough for right now. And we can actually use this one since that's my actual rotation to produce some image points. So let's go ahead and do that. So xy goes to negative yx. So we're going to flip it around. So if I have 2, 1, according to my rule here, this guy, if I have 2, 1, that should travel to negative 1, 2. So negative 1, comma 2, we'll call this A, and so call this one A prime. 2, 3 should now travel to negative 3, 2. So negative 3, comma 2. So we'll call this B prime if we call this one B. And then 5, 1, again, feeding into my rule right here. 5, 1 should go to negative 1, 5, which is going to be off my grid, but that's not a big deal. Negative 1, 1, 2, 3, 4, 5. And so that's C prime, if we call that C. Now, again, this is kind of what we predicted. I kind of had some forethought into trying to show you like kind of what it would look like to rotate. And I said it would be kind of more like this around the origin. We're not rotating in place, although that's a whole lot more convenient and a trick we'll totally use later. But this one, we're rotating around the origin, so kind of orbiting the origin. So everything is moving. So let's get back into place. So about right there. Okay. So this is great if we're always rotating around the origin, but you know that's not going to be a realistic thing. Like if all the rotations we ever do about the origin, what's the point of doing them? It's not applicable enough universal. And so if these rules are all we have right now, we're in trouble. So we should probably do something else to try to extract a rule. So like reflections, let's talk about the structure. Let's see if we can pick out something about the structure that's usable. And so what I want to think about, because we noted that the important parts are the center of rotation and the angle of rotation, let's see if there's any kind of relationship that can pop out at us. So let's use green. So the center of rotation is here at the origin, so let's note that as a single point. We have the pre-image point A, so let's draw a quick little line here. And then we have the image point, which is A prime, which is this guy right up here. So if you look at those 3 points, hopefully you're seeing something, especially if you note that the angle of rotation was 90. And then if I look at these 2 lines and I look at the angle between them, wait a minute there, that looks like a 90-degree angle to me. Maybe that was an anomaly, so let's look at the other ones too. Let's look at B, come down to the center, and then out to B prime, which is this guy over here. That sure looks like a 90-degree angle as well. Not only that, it seems like these arms are about the same length. Last class period, we started using like taxi cab geometry to look at distance. So if we look at the distance from B to the origin, that's down 3 over 2. Well, if I look at the distance out to B, looks like I'm just flipping some numbers around, so just it's out 3 then up 2. That's interesting, isn't it? And then if I look at C and C prime, it's going to get awfully messy if I do it, so I'll do it in a really light color. If I come straight in from C to the origin and then C down here, look at that, another 90-degree angle and 1551. So hopefully in my very subtle way, you guys have picked up on the structure that has to be present here. We can even take a note of it as well. So in the structure of rotations, the angle from image to center of rotation to pre-image equals the angle of rotation. Let's go red. Let's highlight this because that is a wonderfully nice point for us. Because if I know if I'm know if I'm performing rotation, I should be able to see that angle of rotation in my actual structure. So if I'm rotating like 180, I'm rotating like 70, 270, whatever have you, I should be able to draw a line from my pre-image, which is my original point, down to my center of rotation, back out to my image, my new map point, and that angle should be the exact same angle as my angle of rotation. Also, those arms should be the same length, which goes a long way to showing this is too going to be a rigid transformation. Uh, and also tells us that we can kind of transform our rule to something a little bit more formal. So like these are all well and good if you're just rotating around the origin. Now we do have a formal rule here. Wow, there we go. A formal rule just like the other two. The rotation, which we'll use a big R for, around 2 points, the center of rotation or angle of rotation, and then the center of rotation. Takes every xy to a new x prime, y prime. Let's change one thing. Let's take that xy and change it to an AB, just so we're not confused with the general rules. And again, don't be confused about this notation or anything. This stands right here. That's just a rotation. So it's telling the reader that's what we're doing. That is the angle of rotation. This guy right here is the center of rotation. This stands for all the points you're going to translate. And these are your image points. Okay. So if I'm going to write the formal rule for this guy, I would write it like this. The rotation about 0, 0 of 90 degrees for all my xy's are going to end up at x prime, y prime, which in this particular case is going to be negative yx. Okay. Formal rules are great. There is of course, a chop down rule that we see probably in Khan Academy the most. So the more generic rule is going to be general T for big transformation about the point AB and about the angle. And again, the unfamiliar bits here, that just stands for transformation. And that is still the point of rotation. Okay, so very formal stuff, but in the end, I would argue this is a big revelation that we need to kind of think about. And I'm going to show you some examples here in a moment how that applies. We can go back and add to your notes or just kind of check it out. But the big revelation is if I have like a point B prime, or I'm sorry, B that translates over to B prime, it should translate by the actual angle of rotation. Like that's why we identify it. So just like all things, if we identify the point as opposed to identifying the whole shape, it actually gets a lot easier for us. Now, last bit that before we kind of move to the examples that I want to kind of think about, like if these lines are the same distance and they're all translating by the same angle or transforming by the same angle, that means that we can call this thing, like the other things, a rigid transformation, which again is really good for us because that means it's not going to change the shape of the object. So a big conclusion we can reach is given the structure and given the algebraic rule, okay, that the rotation is a rigid transformation. Which hopefully this is the third time you're hearing it, so it's starting to sink a little bit. Rigid transformation is the same thing as a congruence transformation. Which also means it will not change the shape of the object. So the shape being rotated will not change. So again, just like with reflections, just like with translations, rotations are a vehicle, not a machine that's going to alter. So like whatever you put into the machine will turn it somewhere else, will twist it somewhere else, but that is all it will do. Um, it's not going to like again change the object from like a square to a rectangle or like from a circle to a triangle or something crazy. Whatever you put into it is what you get out of it, which again is really good news for us because if our main objection was that you couldn't do this stuff, I think we've just now proven pretty definitively you can using any of the transformations available to you. Let's look at some examples, and you probably want to put these into your notes in some way. That's what I would do if I were you. Like your notes aren't complete unless it has everything you need, right? So uh, this is asking us to identify the transformation, and you look there, you just have the angle that rotates a blue solid shape onto the orange shape. So here's where you have to kind of make this assumption that if they're not telling you, the center of rotation is at the origin. So if so, we all we really have to identify, since we can assume the center of rotation is here, we just have to identify the angle, which is what it's asking us for. Now, again, note that we're looking for the blue to the orange. Like that's an important piece of this because in this case, direction does matter because we're starting with the blue, ending at the orange. So let's talk about some tactics that can actually help you do this really well. Let me switch back here and zoom in just a tad. Okay, and so if this was me doing this problem, the very first thing I would do is map one point onto another point to its matching point. So take this top one. That's definitely, if you kind of use your intuition, it has to map right here. So like this would be like the equivalent. I'm writing with my mouse right now, so sorry, it's gonna be really messy. So this would be like our A, and this would be like our A prime. So knowing what you know about the structure, which again I pointed out was a more important thing other than just like the rule. If you think about the structure, if I connect my center of rotation, which is right there, so that's my center of rotation. Come on, we can do it. Let's get that R, close enough. So if I connect my pre-image, which is this A, to the center of rotation out to the A, I bet you guys can already see it. That's going to reveal the angle of my rotation. And so hopefully you're seeing that's a 90 because again we have to default to going counterclockwise. So blue to orange, A centered, A prime, that's got to be a 90-degree angle. Now if we don't see it with that one, we can try the other ones. So this guy right here, let's call it B. Oh no, sorry, this guy right here. Call it B. Has to map onto B prime. So again, if I take, I'm trying to make a dotted line and I'm failing horribly. If I take a line from B to the center of rotation out to B prime, again, you're seeing like this right angle. In fact, that's got to curve for pretty much all the points. Let me clear out. So let's take this guy called C, and that's got to map here to C prime, just using what I see about the shape and my intuition. Those have got to be matching. So if I look that to my center of rotation, boom, center, boom, there's my right angle. And so they're all right angles, so that would lead me to believe that this definitely has to be a rotation of 90 degrees. So let's back out and see if I'm right. Got to hear weird drawing. So 90 degrees counterclockwise. And lo and behold, we're correct. Let's try another one. Uh, oh, this one's a little bit different. We want to map the polygon with a rotation of 180. But we can actually take a similar tactic. Again, let's assume the center is at the origin because we weren't told otherwise. So that will be our center of rotation. And so if I take this point, let's call it A for now, and I draw a line from here to my center, that has to be at a 180-degree angle with a new point. Now, 180-degree angle is just a straight line. So if I continue this the same distance and I came over to down 4, so this means I have to go down 4 over 2 if I want to use the same distance again. I would say it has to map right there. Let me switch over to my this guy. So if I take this point and I rotate it around, come on guy, I rotate around to this point, that should be a 180-degree rotation, because if I take this line and extend it from my pre-image all the way to my image, A prime, this angle that's formed is 180 degrees. It's a straight line. And we can see that kind of with the other ones. Like if I take this point through the center of rotation to there, that's a straight line. Here through the center, straight line. So again, this leads me to believe that we're probably correct. Let's go ahead and check this guy out. And we totally are. All right, let's try another one. Here's another one where it's going to give us now 270 degrees. So here's where I want to bring in this idea of negative angle. So if an entire rotation is 360 degrees, 270 would be like 1, 2, 3 rotations. So like if this is 360, each quarter is 90, which means 270 is to right here. So negative in math just means opposite. And so if I'm assuming everything is counterclockwise, if I take negative 90, that just means 90 degrees in the other direction. So like negative 90 would just be 90 degrees clockwise. So I can think of this as a 90-degree rotation going like a clock does instead of 270 going the other way. That's all kind of the idea of a negative angle. It's just really about direction. So let me try to explain a little better what I mean. Let's go to my pen. So again, we have to assume the center is 0. So let's go 0. So if I just take like any of these points, let's say like this guy right here, and I'm choosing it specifically because it is on an axis. If I'm going to rotate it 90 degrees clockwise, so negative 90, because negative 90 is the same thing as 270 the other way. And then I kind of map out that 90. So again, drawing a line from my pre-image to my center at a 90-degree angle back out to into a clockwise direction. That means A has to end up right here at A prime for it to be that rotation. Let's check that out. So A, come on little guy, you can go. There it goes. So A to A prime. Again, there's that 90-degree angle from A, where it was, a dotted line to the center, out to my new point. Negative 90, same thing as 270. 270 would have just looked like this. So like 90, 180, 270. So same exact thing. It just I wanted to introduce the idea of negatives to you. Let's check out if we were right. And you didn't see it, but it says we're right. I guess I can zoom out a little bit. See, we're right. Okay. So not too bad. Again, the structure is really kind of where the strength of this comes into play. So what's the transformation that rotates the blue solid shape to the orange? So we're going to blue to orange. You know what I'm going to do. Like you have a good sense right now. I'm about to draw some angles. I'm about to pick a point, pick its image and pre-image point with a center, assumed to be at 0 in this case. We're going from blue to orange. So if I take, I don't know, this point right here and draw it to my center, that's going to map this guy right here. Boom, boom, boom. So I draw it back out to that guy. That's going to be A prime. And again, I'm picking that out just because I'm looking at the blue shape, looking at the orange, and I'm reasoning in my head it's got to map to that. And of course, because we're looking at standard rotation, it's got to be clockwise, or I'm sorry, counterclockwise. That looks like a 90-degree rotation to me. And so Let's go 90. Correct. Let's see. We only have one more to go, so let's get this 5 in a row. Okay, so what's a polygon with a rotation of 180? This is going to be real quick. You know what I'm going to do. Here's my center. I'm going to pick this point because it's on axes, which makes it easier to rotate. It's got to be 180 degrees, so I know the line has to go from here to the center and make a straight line, which means it's going to probably be right there to A prime. And I wrote upside down for some reason. Just go with it. I am rotating counterclockwise, so, and let's check it. Come on, Khan Academy, do it. All right, there we go. All right, so that's what I got to say about rotations. Um, Again, there is a rule that goes with this. It's not nearly as important as understanding the angle piece involved. You'll be responsible, of course, for like the 90, 180, 270. Those are benchmarks. Those are normal. But we'll also explore angles that aren't that. And in the end, it's all just about showing the angle between the image, the pre-image, and the center, right? So that was kind of a longer video, but rotations are new to us. Take those notes, do the Khan Academy quiz, get a good grade. Thank you.